So the group 17 of the periodic table that include the 5 elements you can see here, that is fluorine, chlorine, bromine, iodine and aspartame. The electron gain enthalpy will become less and less negative down the group because of the increasing in atomic radii. The hydrogen fluoride is a liquid at room temperature due to the strong bonding, while the other halides are usually gases. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called the P block elements. Under this unit, we have discussed about the sulfur and its allotrope. Under that, we have discussed about the monoclinic and rhombic sulfur. In addition to that, we also discussed about the chemical properties of sulfur, and we also discussed about the uses of sulfur dioxide, which are the compounds of sulfur. And also we have talked about the manufacturing of sulfuric acid by contact process, and already I have explained that it is one of the important question for your board exam. And coming into the chemical properties of sulfuric acid and the uses and the oxo acids of the sulfur, we have discussed in our last discussion. Today, we will move on to the next topic of this unit by understanding the group 17 elements in the periodic table. And also, the electronic configuration we are going to discuss, their occurrence, oxidation state, trends in their physical property and the anomalous behavior of the fluorine we are going to understand in this session. Let's see what are the group 17 elements in the periodic table. So we are very much familiar with the periodic table, right? So in that, we know that group 17, they are known as halogen family, and it includes fluorine, chlorine, bromine and iodine as well as aspartame. Okay, so the group 17 of the periodic table that include the 5 elements you can see here, that is fluorine, chlorine, bromine, iodine and aspartame. These are the group 17 elements and they are generally known as what? Halogen family. And halogens of the P block elements are the last differing electrons are enters to the NP subshell. If you see that all these elements, the last electrons are entered to the P block, hence it is belonging to the P block elements. And there are 7 electrons will be there in the outermost shell. Okay, and these elements have 7 electrons in their outermost shell. Among them, aspartame is a radioactive. If you see that 5 elements, the last elements in this group, that is aspartame, which is radioactive in nature. Hope you are understood with the introductory part of this group 17. So why the group 17 are known as halogen family? Because it includes the halogens, that is fluorine, chlorine, bromine and iodine and aspartame. Okay. Coming into their electronic configuration, it is very important to understand their electronic configuration of group 17 element. Already I have told that in their valence shell, it consists of how many electrons? 7 electrons. We will see one by one. First, I'll go with the fluorine. We know that fluorine has an atomic number 9 and its electronic configuration is 2, 7 and their inert gas configuration is helium NS2 NP5. And if you consider only the valence shell electronic configuration, it is NS2 NP5. You can see that 2s2 2p5 and in general you can write NS2 NP5. NS2 NP5 and you can count that there are 7 electrons will be there in its outermost shell. Okay, and coming into the chlorine, the atomic number of the chlorine is 17 and the electronic configurations will be 2, 8, 7. So in the last third shell, you can see that again there are 7 electrons will be there, and the inert gas core configurations will be goes like this, that is neon 3s2 3p5. If you see that valence shell electronic configuration, it is 3s2 3p5. Again you can count that it consists of how many electron? 7 electron in its valence shell. Okay, coming into the bromine, and it has atomic number 35. You can say that it has its electronic configuration of 2, 8, 18 and 7, and the inert core gas configurations will be goes like this, argon 3d10 4s2 4p5. And here also you can observe that the valence shell electronic configurations of this bromine, which consists of 7 electron, and it will be written as 4s2 4p5. And coming into the iodine, it has an atomic number of 53 and the electronic configurations will be goes like this, that is 2, 8, 18, 18 and 7, and the inert gas core configurations will be krypton 3d10 5s2 5p5. Again you can see here the last shell that consists of 7 electron in their valence shell, hence the valence electronic shell configurations will be 5s2 5p5. And coming into the last one, that is astatine, and it has an atomic number of 85 and electronic configurations will be goes like this, 2, 8, 18, 32, 18 and 7, and inner gas core configuration is xenon 4f14 5d10 6s2 6p5. Again you can see that the last shell, which consists of 7 electron, and the valence electronic configurations of the last valence shell can be written as 6s2 6p5. In all these elements you can see that the last shell, which consists of how many electrons? 7 electrons as their valence electron. Okay, and you can see that last electrons are going to enter for the p orbital, hence it belonging to the p block elements. So, and generally we can represent this valence shell electronic configuration as ns2 np5, and it indicates that there are 7 electrons in their valence shell. Okay, that is why they are known as group 17 elements. Coming into their occurrence. So it is very important to understand the occurrence of this group 17 elements in the nature. Okay, the fluorine and chlorine is quite abundant, but bromine and iodines are not so. And fluorine are mainly occurs in fluorides, that is as CaF2, that is fluorophosphor, and cryolite, that is Na3Al F3 and fluoropatite, that is Ca3PO4 2 times and CaF2. So this indicates that the fluorine will always exist in the form of fluorides. Okay, and in small quantity it will be present in the soil, river, as well as in the water, and in the bones as well as in the teeth of the animals. Seawater, which contains chloride, bromide and iodide of the sodium, potassium and magnesium and calcium. How it will be present? That will be present in sodium chloride in the form of sodium chloride, sodium iodide, sodium bromide, similarly potassium chloride, potassium iodide and potassium bromide. Similarly, the calcium chloride, calcium iodide and calcium bromide. Like this, the chloride, bromide and iodide can also present with the sodium, potassium and magnesium as well as with the calcium. Similarly, the magnesium will consist of magnesium chloride and magnesium iodide, okay, then magnesium bromide. Okay, like this, the chloride, bromide and iodide will be present along with sodium, potassium, magnesium and calcium. But the seawater will be mainly consist of what? Sodium chloride. We know that how does this sodium chloride, which is also get extracted from the seawater. And various seaweeds which also contains nearly up to 0.5% of iodine. And child saltpeter will also consist of little of iodine as a sodium iodide. So these are the important occurrence of the group 17 elements. Coming into their oxidation state. Already I have explained that the group 17 elements has a valence shell electronic configuration of Ns2Np5, right? So in order to get a stable electronic configuration, either it has to accept the one electron, either it has to share its all 7 electrons to form a other elements, right? So that is why we can say that the group 17 elements which exhibits -1 oxidation state. How come? Because you can see that the valence shell electronic configurations which consists of 7 electrons. In order to get a octet electronic configuration of 8, either it has to accept 1 electron, right? Suppose if it is accepting of 1 electron to get this stable electronic configuration of 8, it shows what? -1 oxidation state. Okay, and fluorine being a highest electronegative elements of this series, they shows only the -1 oxidation state. Rest of the elements of this group, they shows the oxidation state from +1 to +7. Okay, however, the chlorine, bromine and iodine, they exhibit the oxidation state of +1, +3, +5 and +7. How it will be exhibits +1, +3, +5 and +7 oxidation state, I'll explain in the next slide. Okay, due to the presence of the d orbitals in their valence shell, all these elements, which are those? Fluorine, chlorine, bromine and iodine. Except this fluorine, this rest of these 3 elements which shows +1, +3, +5 and +7 oxidation state, whereas our fluorine will shows only -1 as an oxidation state because there will be a no presence of d orbital. That is why the fluorine will shows only the -1 oxidation state, and I am going to explain definitely with that why -1 oxidation state will be exhibited by the fluorine while writing the ground state electronic configurations. Hope you all understood with the oxidation state. We'll see with this halogen atoms with the ground state electronic configurations. So this is a ground state electronic configuration of halogens, that is fluorine, chlorine, bromine and iodine. Okay. So what is the general electronic configuration of the valence shell? That is Ns2Np5, right? So in Ns2 you can see that there are 2 electrons, whereas in Np you can see that there are 5 electrons will be there, and this is the general electronic configurations of its valence shell. Generally, what it will do, this halogen groups of elements, in order to get a stable electronic configuration, it requires how many electrons? 1 electrons it requires, right? So it requires how many electrons? 1 electron. That is why all this group of elements, they accept 1 electron from the other element, thereby it shows what? -1 oxidation state. So I am talking about all these elements which shows -1 oxidation state simply by accepting the 1 electron. But we have exceptional cases with chlorine, bromine and iodine. We'll see what it is. Okay. If you consider the chlorine or bromine or iodine, in the first excitation state, you can see that the Np which consists of 5 electron, in that the Px, Py and Pz. Okay. This is again Px, Py and Pz. One of the electron from the Py will be got shifted to the d orbital, empty d orbital. Thereby, it shows 3 unpaired electrons. So, this indicates that all these three elements, that is chlorine, bromine and iodine, in the first excitation state, it can pull one electron towards the empty d orbital, thereby it shows +3 oxidation state. Thereby it shows what? +3 oxidation state. Similarly, in the second excitation state, you can see that again this is Px, Py and Pz. Okay. Again, in the second excitation state, one of the electron from the Px has got shifted to the empty d orbitals. Thereby, it shows how many unpaired electron? 5 unpaired electron. Thereby, it shows a +5 oxidation state. Okay, remember the fluorine will not show all this oxidation state, only it shows -1, because for the fluorine there will be no availability of the d orbital, but rest of this, all this element have a empty d orbital. That is why it shifts this electron from the p and s orbital, thereby it shows a +1, +3, +5 and +7 oxidation state. Okay, and coming into the third excitation state, again one of the electron from the s orbitals, got shifted to the empty d orbital, thereby it shows 7 unpaired electron. This indicates that it can shows a +7 oxidation state. So this is how we can clearly understand that how does this halogen element, especially the chlorine, bromine and iodine, they shows a +1, +3, +5 and +7 oxidation state in addition to the -1 oxidation state. Okay. The higher oxidation state of chlorine, bromine and iodines are achieved when halogens are combined with a more electronegative elements like fluorine only. Okay, and oxygen, and thereby it forms a interhalogen oxides or oxo acids. Suppose if the chlorine is there, if it is combined with the fluorine, both we know that these are the halogens, right? So if these halogens are formed, they usually have a higher oxidation state, thereby such compounds are known as what? Interhalogen compounds. Why it is known as interhalogen compounds? Because between the two halogens, the bond which has been formed, right? Hence it is known as what? Interhalogen compounds. Suppose if it is combined with the oxygen, thereby it forms what? Oxo acids. More about this interhalogen compounds I am going to discuss at the end of this topic. Okay. The chlorine, bromine can also exhibit oxidation state of +4 and +6 and their oxides and their oxo acids. Due to the absence of d orbital, already I have explained that the fluorine will not show +3, +5, +7, even though the +1 oxidation state will not be exhibited by the fluorine because of the absence of empty d orbital. How to know that? We know that the fluorine has an electronic configuration of 9, right? And how do you write it? It is 1s2, 2s2 and 2p5. You can see that there is no availability of the d orbital. Hence, this fluorine will not shows +1, +3, +5 and +6 and +7 oxidation state. Thereby, it do not attain the octet structure. Coming into the trends in their physical property. The first trend is atomic or ionic radii. As we all already know that atomic radii, it is nothing but a distance from the center of the nucleus to the outermost shell. As we move down the group, that is from fluorine, chlorine, bromine and iodine. As we move down the group, that is in a group 17 elements I am talking, thus atomic radii will be increased. Why does this atomic radii will be increases? We know that as we move down the group, number of shells are increased. As the number of shells are increases, automatically the distance from the center of the nucleus to the outermost shell, which is also going to be increased. Thereby, ionic radii, atomic radii, both will get increased. Coming into the ionization enthalpy, we know that ionization enthalpy is nothing but energy which is required to remove the electron which is there in the outermost shell. We know that as we move down the group, this ionization energy will be decreases, because as we move down the group, what will happen to the number of shell? It is going to be increased. If number of shells are increased, automatically it is very easy to remove the electron from its outermost shell. That is why this ionization energy will be decreases down the group. And coming into the electron gain enthalpy. We all know that already this group 17 elements has a higher capacity to accept one electron from the other element. Thereby, it releases energy, that is nothing but the electron gain enthalpy. And it shows a maximum electron gain enthalpy of this group. Okay, so the halogen have a maximum negative electron gain enthalpy because of the elements have only one electron which is lesser than their noble electronic configuration. Hence, we will written as NS2 NP5. To get a stable electronic configuration, it has to get NS2 NP6. So, only one electron differences is there. That is why it shows a maximum negative electron gain enthalpy. That is one of the speciality of the group 17 elements. And the electron gain enthalpy will become less and less negative down the group because of the increasing in atomic radii. As we move down the group, it will become more and more negative, or you can say that less and less negative. Okay. And electron gain enthalpy of fluorine is lesser than that of the chlorine. This is very, very important. Okay. For the 2 marks, they can ask you why the electron gain enthalpy of fluorine is less negative than that of the chlorine. If you see that the elements which is present in this group, the fluorine has less electron gain enthalpy as that of the chlorine. That is mainly because the smaller size, hence a larger electron density of the fluorine atom. Hence, the incoming electrons are actually experiences a little attraction. In such of this group, Cl has a maximum negative electron gain enthalpy. I can show you that. We know that the fluorine has a 9 electron. Now, if you see that electronic configurations of the fluorine, so if you see that in the first shell it consists of only 2 electrons, whereas in the next shell it consists of how many electrons? Remaining 3, 4, 5, 6, 7, 8, 9 electrons will be there, right? In order to get a stable electronic configuration, already I have told that either it has to accept 1 electron. When this fluorine are accepting 1 electron, it feel more repulsions. As a result of this, the electron gain enthalpy become very less for the fluorine as that of the chlorine, because if you consider the chlorine, it can easily accept 1 electron to get a stable electronic configuration as it is compared with that of the fluorine, because of the smaller size of this fluorine, and also it experiences the more repulsion and it experiences a very little attraction towards the electron. That is why the fluorine has less electron gain enthalpy as that of the chlorine. Okay. Next is electronegativity. These elements have a higher electron negativity, and electronegativity will be decreases down the group. Okay, as we move down the group, what will happen to the electronegativity? It will be started decreasing because of the increased effective nuclear charge. Okay, coming into the oxidizing power. So, we must understand how those halogens will also have a oxidizing nature. We will see with some of the reactions so that we will understand this, how this oxidizing nature of the halogens can also be explained. Okay. All the halogens are strong oxidizing agent because of the strong tendency to accept electrons. So, they have more tendency to form bonds with other elements, thereby it accepts one electron, so that bonds will be very stronger, right? So that is why their oxidation states will be, their oxidizing nature will be very strong in their nature. And halogen oxidizes the iodide ion of higher oxidation number. So here I have listed out the few reactions where you can see that the fluorine, chlorine and bromine, if it is reacting with other halogen, thereby it forms a fluoride, chloride, bromide, iodide, etc. Okay, this indicates that they are very good oxidizing agent, and oxidizing ability of the halogen in aqueous solution will be decreases down the groove, and it will be implemented in such a way. You can see that first it will be in the gaseous state, next it will be become a gaseous. After accepting of one electron, it will become Z minus, and it will also become X minus. Here the X stands for what? Halogen. Okay, and the fluorine will oxidize the water to the oxygen, whereas the chlorine and bromine react with the water to form a corresponding hydrohalic acid and hypohalic acids. This actions of iodine with the water will be non-spontaneous. In fact, the iodine can also oxidizes by the oxygen in the acidic medium, and just it is a reverse process. Here you can see that reaction. How does it will be formed? You can see here the fluorine reacts with the water, thereby it forms a H plus ion, 4F minus ion and releases the oxygen. Similarly, you can take a chlorine or bromine. It can also react with the water, and thereby it forms a hypohalous acids and HOX. But iodine, it indirectly reacts with the water, thereby it forms a iodine. Okay, but it is a reverse reaction, thereby we can understand that iodide can react with the oxygen only in presence of aqueous medium of H plus, that is in acid medium. It gives to what? Iodine with the water molecule. This is how, when it is react with the water, it gives to the hydrohalic as well as with the hypohalic acids will be formed. Next is physical state of this group 17 element. Okay, on account of weak intermolecular forces, the halogens are volatile in nature, and these forces increases from fluorine to iodine, and hence the fluorine and chlorine are gases, whereas bromine is a fuming gas and iodine is a volatile solid at a ordinary temperature. And halogen exhibit the gradual variations in their physical property, and their melting point and boiling point gradually increases down the group because of the increasing in atomic number. And all halogens are colored, and this is due to the absorptions of light at a particular frequency, thereby especially at a visible region, thereby it exhibits the color to the compounds. And you can see that the fluorine is a pale yellow, whereas the chlorine is a greenish yellow, bromine is a reddish brown, and iodine is a deep violet. Hope you know that while doing the salt analysis in your laboratory, if bromine is there in your compound, it gives a brown fumes, the gas which is coming out, that confirms that bromine will be there in our compound. Whereas fluorine and chlorine react with the water, and bromine and iodine, which will be sparingly soluble in water, but organic solvents such as carbon tetrachloride, carbon disulfide and chloroform, and gives the color to the solution. Then the last one is the anomalous behavior of the fluorine. So as we know that the group 17 elements will be start with the fluorine, chlorine, bromide and iodine and astatine. The fluorine is the first element, and obviously we know that the first and second elements of this P block element, they usually differs from the other rest of the elements because of some of the special characteristics, right? So in this group also, the fluorine which looks different from the other rest of the elements, thereby it shows its anomalous behavior. That is mainly because the first thing is the fluorine which is having a smaller size and it has a highest electronegativity and it has very low fluorine-fluorine bond and their dissociation enthalpy which is also very less, because between the two fluorine atom, since it is a small atoms, bond dissociation energy which is also very less. Because of the smaller size, we can easily break this bond, okay? And absence of the d orbital. Already we have understood that this group 17 elements in that fluorine will have a exceptional case because they do not have a presence of d orbitals. That is why due to the absence of this d orbitals, they shows only the -1 as their oxidation state. And most of the reactions with the fluorine are exothermic and it gave rise to the only the -1 oxidation state, and it is a positive oxidation state in addition to the -1, whereas the other halogens if you consider. And it gives no oxo acids while others will give some many oxo acids, okay? And the hydrogen fluoride is a liquid at room temperature due to the strong bonding, while the other halides are usually gases, okay? In the next session, again we are going to discuss with the chemical properties of group 17 elements. So by this, I conclude that whatever the things which I covered in this session, again it is very important for the examination point of view as well as your competitive examination point of view. Have a look on it. We will meet you with the next session. Till that, take care. Be safe. Thank you.